Yeah, hello guys and welcome back to my channel again. So as you can see, today's date is 17/10 and I'm going to present a video assignment regarding my subject which is taught by Suraj sir, and I'm holding USN 117 as I can say. So my today's video's topic is artificial intelligence. In this video, I'm going to share you about some of my key points or key insights of research paper which I have been studying from past 1 week. So from past 1 week, I was having so much of research papers in my computer and I was studying them. And the best one I found it, and I would like to share that in my video assignment as well. So yeah, as you can see here, my name is Vishal Niranjan and I'm holding USN 1 CS. Currently studying in Associate Bangalore in third year. Yeah, so quickly we'll jump into our video. So yeah, so this is my 1 second. So as you guys can see, this is my video regarding boosting neural videos codecs by exploiting hierarchical redundancy. So yeah, this is regarding AI. We are not talking about anything else in this video. So this research paper was by Reza Only, Amir Said, William Sotre, okay, Wiggles, and Qualcomm AI Research. So these are the keywords of that research, and these are the publication journals of the research. So yeah, quickly we'll just see what is the video about. Yeah, as you can see here, so these are the citations. We don't need any more. This I don't need any more. This also I don't need any more. We'll quickly jump on to this, which is about the research paper you provided discusses about advancements in neural coding. What is neural video coding? We will quickly see about it, focusing on improving compression and efficiency by addressing both first order and second order redundancies in video frames. Here are some key points and highlights from the paper. As you can see, I have mentioned some of the key points here. So yeah. So yeah, sorry for the inconvenience, guys. So here you can see my video is about this topic. So yeah, what we'll see in this topic, these are some key highlights. So, first of my key highlights is hierarchical redundancy in video. So, what is hierarchical redundancy in videos? What are the redundancy? What is hierarchical redundancy in video? So, the authors define two levels of redundancy. The first order is we don't need this anymore. I'll just quickly erase this. So, the author is providing about some of the redundancies, that is first order and second order. So as you guys can see here, the first order redundancy is the first order redundancy is first order similarities in pixel values across the neighboring frames are effectively captured through motion and residual compensation. So second we are seeing here is second order redundancy. Redundancies in motion and residual maps due to smooth motion in videos, which this paper aims to exploit using predictors. So yeah, these are the two highlights about this, and as I have mentioned, so the first order redundancy is basically talking about similarities in pixel values across neighboring frames, like what will be the next frame going to about. So effectively captured through motion and residual compensation. Second order redundancy will talk about redundancies in motion and residual maps due to smooth motion in videos, which this paper aims to using. So quickly moving into this topic, which is also about yeah. So this topic in this video, this introduction to predictors. So what are predictors? The paper introduces generic motion and residual predictors designed to learn from a previously decoded data, enabling the capture of second-order redundancy. So the paper is introducing about generic motions and residual predictors designed to learn from previous decoded data, enabling the capture of the first second-order redundancy. So these predictors are lightweight and can be integrated with existing neural video codes to enhance the rate of distortion performance. So as you guys have some distortion and red distortion errors, so these predictors are used for that. So after that, we'll quickly jump on to second topic is about this. So the color space and considerations. Most neural video coding literature focuses on the RGB color spaces. This study emphasizes the U420 color space, which is closer to human perception and leads to the bandwidth savings. Yeah, so this is what I was going to tell you about, guys. So color space consideration is the most hard part of the video or neural video coding. So in color video, so anything you can see is based on RGBs, right? So this study emphasizes the UA color space, which is closer to human perception and leads to bandwidth savings. So the authors demonstrate that their codec can effectively operate in both RGB and U420 formats with minor architectural adjustments. So yeah, minor architecture corrections, as I say. This video is always about this RGB and UVA for U420 format with minor architecture, so that they can integrate it easily through the neural videos and neural networks across the videos. So fourth point about my research paper study was like experiments show that integrating the proposed predictors with non-neural video codec leads to a significant repeat rate, about 38% in RGB and 34% in U4420, as measured on the UVG dataset. So this UVG is a dataset for U4420 and RGB neural network. So bitrate has a significant amount of how many pixels you want, how many bitrates you are saving, how many on which resolution you are saving your video. So the resolution can affect more in this video network neural network. So yeah, performance improvements is always a key point in any research paper. So this also having performance feature. So yeah, this will always improve our performance regarding this. And quickly, if I jump on to the next topic, that would be my methodology overview. So the proposed method consists of four steps in interframe coding process. So we talked about hierarchical redundancy in video. We talked about this introduction to predictors. What are predictors? Yes. So lastly, we talked about color space and considerations, like how the color space is considered in the multi-neural networks. And after that, we talked about some performance improvements which this research paper can implement in the industry, right? So now we'll quickly move on to the methodology overview. The purpose consists of four interframe coding process. What we do you mean by interframe coding process? As we discussed that this research is all about the neighboring frames and consideration the RGBs of the frame. So the first flow is prediction, the flow prediction. How the frames are flowing, predicting the flow for the current time step using historical frames. Well, historical frames nothing but are the neighboring or the previous frames which we are considering. So second one is flow compression. So flow compression is correcting and compressing the predicted flow. So these two are the first two highlights or first two methodology of this overview. And third one, we will talk about residual prediction, the predicting the residual for the current frame based on the motion compensated frame. So predicting the residual of the for the current frame based on the motion compensated frame. The motion compensated frames are the neighboring frames or the previous frames which were having to be considered as RGB in 420. So as we saw here, it can reduce about this. Wait a second. Where it is, where it is. So it can always this and this. Easily, if we talk about this, these are the main keyword and highlights of the sequence, right? And again, if we move on to so the third was the residual prediction. What is residual prediction? Predicting the residual for the current frame based on the motion compensated frame. And fourth and the last methodology of this research paper was the residual compression. What that means, the correcting and compressing the predicted residue. Like correcting and compensating the predicted residual is the most important part as we can see here. So it's nothing but just overview that how this frames will be compensated during this video and video codecs. So yeah, this was the methodology. We saw performance improvements. We saw color space. I don't need this anymore. I'll just quickly erase it. Yes, third is this. Fourth, introduction and this. So fourth was the performance improvement and this methodology overview. So now we'll quickly just look what is this technical architecture. So talking about artificial intelligence, it always work about some technical architecture. It is always having some architecture, some models, some LLMs. So some big data set models which we use for the compressing. I'll just quickly get this into the main screen. So talking about the architecture includes flow pred and rest pred. So flow prediction and residual prediction networks that utilize an R-glass structure for prediction. So the R glass, as you can see, what is R glass? R glass is basically somewhat like we'll see here also are having some options for AI. So we'll quickly generate an R glass. Yeah, just I want to generate the R glass. That's the thing I want to do. R glass showing sun and tide. So quickly will generate. Yeah, as you can see. So the R glass structure is talks about this. So the R glass structure about this the top chamber with sand, neck of R glass, the limited sand supply, bottom chamber, controlled flow of sand, the time measuring and collecting sand. So similarly, there is no other process in this. So basically, R glass structure is for prediction. Like first, they let's say we'll have one video. Let's say the top chamber with previous three frames. Yeah, and the next leg of our glass, the limited sand supply. So the limited sand supply would be limited frame supply here. Sorry. So bottom chamber and controlled flow of let's say video, not video. We'll just talk about frames here. So controlled flow of flame, time measuring is collecting frames as well as what we are collecting RGB and connecting U420 in that. So yeah, so time I love the time measurement and this things. So basically, I don't need this anymore. I'll just quickly erase this all thing. I'll just quickly erase this. So yeah, moving on to our video topic. So a high prior network flow AE and res AE that conditions on bottom like features from flow frame and flow racing. The first frame is encoded as an intra frame while the subsequent frames are treated as an interframes. So first flow will be obviously like that, and now we'll quickly move on to the last. I think not last, but yeah. So significance of findings. What is significance of finding? The work highlights a shift towards the leveraging second-order redundancy in neural video codecs, which has been largely overlooked in existing literature. So this work highlights a shift towards the leveraging second-order redundancy in neural videos codecs, which has been largely, I'm not saying largely, but it has been this era of generative AI, generating videos, generating photos, generating codes is like a fraction of seconds we can do easily, right? So yeah, so largely overlooked in existing literature. The findings suggest that optimizing for human perception through U420 can lead to better performance compared to traditional RGB based approach. So when we are using U420, it can lead to better performance compared to traditional RGB based video approaches. So, lastly, I would like to conclude the session. Not conclude basically, I would like to show you guys what was my conclusion for this particular session. Yeah, so the research provide a comprehensive framework improving neural video compression by addressing both the first order and the second order redundancies through the innovative predictor. This approach not only enhances the compression efficiency but also aligns more closely with humans with human visual perception by utilizing the U420 color space. So these points should have serve a solid as foundation for my my I was talking about my video, allowing you to explain both technical aspects and the significance of the research clearly. If you need further details or specific explanations of any section, feel free to ask me anytime in my comments or anything. So yeah, this this was my this this was my this was my review for the paper. And thank you guys for making this video quite engaging as interesting. Yeah, thank you guys, and I'll show you guys on what research paper I was talking about. So yeah, I'll quickly share on this points and This was my first. We saw this about key highlights. The first we saw about hierarchical redundancy. The second was about an introduction. The The second one was about colors based considerations. The fourth one was about our performance improvements. The fifth point was of our methodology overview, like how the video of an interface coding process was there being had. So technical architecture we discussed about significance of findings, and lastly we moved on to our conclusion part. So the research paper I was talking about is this. I personally, if it is free to use about for all the, so I'll personally use this research paper link in my description. You can always see this was the color space we were talking about. This was the method. This was the basic code. Yeah. So see, this was the basic frames, how these frames are working, how this video neural coding is being processed, like with this some highly complicated formulations about this video neural codecs, RGB and URV architecture we have discussed. These are some diagrams of the bottleneck, concat, and yeah. So bottleneck, what we see about our hourglass diagrams over there. So yeah, network architecture, experiments in network architecture, how this will survive, and this all things we saw. We saw this all things. Yeah, so these are some graph about UVG, HVFG, uh, bit rates per second, rates per bits per pixel, bits per pixel. Yeah. So yeah, these are some more diagrams about the conclusion and impact statement. So these are the all reference where this research was successfully published and held. Yeah. So hereafter I'll be concluding my video. These are some supplementary materials from also second standard codecs and etc. So yeah, as of now I'll be ending my video assignment. If you guys have any doubt or any clarification, you can happily ask me in my comments. I'll personally explain you guys about this research paper, which I have been studying from past 1 week. So yeah, thank you guys, and see you guys in the next video assignment with other new topics and interesting things. Bye bye.